Hello everyone. So, on a blackboard, just like this fake one, the numbers 1 to 20 are written. And I walk up and choose two numbers at random. Say I pick 1 and 2 for convenience. And then I erase them, erase one permanently, and then replace the other one with the formula of the numbers I took, which we call a and b. The function a and b is ab plus a plus b. So in this case, if I took 1 and 2, I then exchange it with 1 times 2 plus 1 plus 2, which is then 5. Now, I keep on doing this process until there is only one number left on this board. And it's gonna be a fucking huge number, I can say you now. But the question is, which number is it? What number is it? Well, okay. So how do we find this out? Because we can certainly not try. I can keep going. Okay, if I erase 5 and 3, just I'm trying to keep the numbers. Oh, sorry, I can erase 3 and 4. Then we get, okay, so we get 12 plus 7. Exactly, so we get 19, and then when you do it with 5 and 19, it's gonna get you like, okay, well, yeah, of course I can do it. Okay, it's 95 plus 5 plus 19. So if I were to raise these two, I would get 119. And then if I do it with 5, you see that times 5, it goes quick, and I have a lot more left. I have 6, 7, 8, everything up to 20 left. And it just gets faster and faster the bigger numbers I pick, right? So you can see this is not something we're going to do by hand. Absolutely not. However, we can deduce a formula with some help from our best friend Wolfram Alpha. So how do we do this? Well, first case, if we would like to make some kind of formula, iterative formula here, we would first have to think about, does order matter? If I pick start with these two, or I start with those two, does that matter? The answer is no, and why is pretty easy to show. Basically, everything you have to do is just show that every combination of f of like a and f of b and c, because what is this essentially? This is choosing b and c first and then combining that with a. This is equal to f of b and f of a and c, and yeah, you get the point, and then you c and a and b. And for this, you just plug everything in, and I'm not going to do that. You can do that. You can pause the video and do that. It's not that hard. Everything is just becomes is just an like a squared plus b squared plus c squared plus ab plus ac plus bc plus a plus b plus c. All of those three combinations just turn out to be this. So that's great. Order doesn't matter. So therefore, we can just pick any order, and it will not make any difference. So I'm just going to pick starting from the smallest, going upward. So what do we want then? Okay, so we want that the first integer, well, that's just 1. We're not doing anything with that. So I'll call my series S. So we have that S1 is equal to 1. and we want that S2 is the combination of 1 and 2. So what is that? That is f of 1 and 2. And what do we want S3 to be? Well, okay, so what have we done? We did nothing with the 1, and then we exchanged the 1 and 2 for a 5, or f of 1 and 2, and then S3 is then combining the 3 with the previous number, right? So that is then f of the previous number, which was S2 and 3, right? So here, immediately, we can see a recursion pattern. So we note that s of n plus 1 is equal to f of, damn, my f's were so nice. Okay, f of Sn and n plus 1. And what is this equal to? Well, this is just,
well, it's Fn times n plus 1 plus Fn plus n plus 1.
and here, unless you're very experienced with solving recursion equations, you would see what this, if we can create a general formula create a function, call it p, such that we want p of n to be equal to Sn for all n's. And I could not, at least, figure out what this would be. And it turns out this p of n was equal to n plus 1 factorial. So if you go to your dear friend Wolfram alpha and plug this recursion formula in with the value, or that s of 1 is equal to 1, then you would get that s of n is equal to n plus 1's factorial minus 1. And we can just check real quick that would work. Well, okay, what numbers did we get before? We got 1 and a 2. Doesn't really, no, sorry, we didn't get a 2. We got a 1, and then we got a 5, which is 6, 3 factorial minus 1. And if you then combined 5 with a 3, then you would get 15 plus 5 plus 3, which is 23, which is 24 minus 1, 4 factorial minus 1. Yes, exactly, 4 factorial minus 1. And look here we have 5 factorial minus 1. So yeah, it seems to work, and I trust Wolfram Alpha also. So this is our complete function, or solution to this recursion equation. And now we just plug in what happens at S20, because then we should be done, right? Well, yeah, that would be 21 factorial minus 1, and that's one hell of a number. You can search up how big that number is, but it's huge. I think it's like 10 to the power of, I don't know, 18, something like that. Maybe more. Yeah, it should be more. Nah, yeah. Anyway, kind of crazy. But yeah, so that was basically everything I had for the video today. And I hope you enjoyed the problem, and I hope Wolfram Alpha helped you also, because he has helped me. So yeah, that was basically everything. Have a good one. Bye-bye.